In this problem, we are told that according to a recent election study, 79% of 375 randomly selected college students voted in the 2012 presidential election. We are asked to construct a 99% confidence interval for this and interpret it. This is slightly different from the previous problem. This time, we are given a percentage outright. So we already know what p hat is without having to calculate it ourselves. We are also given that our sample size is 375, and we are given a confidence level directly. Let's sketch out how this problem should go before we go any further. Step 1 is to find p hat, which was given to us, and then from that, we'll get q hat. Step 2 is to take our confidence, find the alpha, and based on that, find the z-critical. Step 3 is to get error. The error, again, is z-critical times square root of p hat times q hat divided by n. We'll be getting our lower bound, which is p hat minus error, and the upper bound, which is p hat plus error. Let's begin by entering what we know. We have an n of 375. We have a p hat of 79%. We'll say 0.79. We also have a confidence level of 99%. I'll leave a space there because we must also get q hat. Now, for q hat, we're going to take 1 minus p hat. So we'll enter equals 1 subtract and click on the p hat. This will calculate our q hat for us. Now our confidence level is 0.99. Based on that, we can get alpha. Now alpha is 1 minus confidence. So in alpha, we'll say equals 1 subtract and then click on the confidence level. This gives us 0.01. Then we can find our z-critical. Our z-critical will be this. Negative norm S inverse. And we'll take that of alpha divided by 2. So we'll say equals negative norm S inverse. Click the alpha and divide it by 2 and press enter. This will give us our z-critical. Now we've gathered up all the ingredients we need to get error. To calculate error, we say this. Z-critical times square root of p hat times q hat divided by n. So let's try this. Equals z-critical multiply square root p hat multiply by q hat divide by n. Close the parentheses and press enter. This gives us our error. Now our lower boundary will be p hat minus the error. And our upper boundary will be p hat plus the error. So here we'll say equals p hat subtract error. And for our upper boundary, equals p hat plus error. These two numbers will be our confidence interval. Now let's draw a picture to symbolize this. Our marker on the left will be 0.73582, and our marker on the right will be 0.84418. Our confidence interval exists between these. This means we can say with 99% confidence that the true proportion of students who voted in the presidential election are between these numbers. Now, question B says, a survey of students at a local college indicated that 62% voted in the 2012 presidential election. Are the results of the survey consistent with the interval estimate? Let's place that 62% on the picture. Now, our confidence interval is from roughly 0.736 to 0.844, but 62% is definitely less than 0.736. 0.62 would fall somewhere here on the number line. Now, since this is not inside of our confidence interval, we can say that this proportion is not consistent with our findings. And the reason why is because it was outside our interval. Had they given us a number that was between the two numbers we found, we would say that is consistent.